Hi everyone, my name is ECG from FKE Today we will continue to talk about the Coulomb's law. So in today's lesson, I'm going to show you an example how to use the Coulomb's law to find the force between two charges. Okay, we have talked about this Coulomb's law, how to find the F12 earlier. So now let's move on to how to find the F21. Okay, so just now is F12, now is F21. So what is the meaning of F21? So you can look at the definitions here. Okay, so for the F21, it is the force acting on Q1. Okay, this is Q1 due to Q2. Okay, so this means that this Q2 exert force, apply the force, giving this Q1 a force. Okay, so F21 is the force acting on Q1 due to Q2. Okay, so what's the difference? You can see here the arrow is pointing to the Q1. So previously the arrow is pointing to the Q2. Okay, so this is different notation used when you want to find the force. Okay, so you must be very clear whether you want to find the force acting on Q1 or you want to find the force acting on Q2. So the other parameter, they are same. Okay, you need to find this one, Q2, Q1, and you have this 4 pi epsilon naught. And for your information, this epsilon naught is the permittivity of free space. Okay, so the value is fixed. Okay, you can get this value from your calculator also. When you press the constants, okay, shift constants and go to the universals, you will be able to see the values, okay, of the epsilon naught, okay, in your calculator. Okay, so I'm using the calculator Casio FX570. Okay, so just press shift constant, then you'll be able to find this value. Okay, so the difference between the formulas, this formula and the previous one, is on the labeling here, notations. So previously we have R12 and this one is R21. Okay, so the difference for the R21 and R12 is the R21 is equals to negative of R12. This is because for the R21, okay, you will be taking, okay, the coordinate of charge Q1 minus, okay, the coordinate of the charge Q2. Okay, this is not coordinate, this is actually the position vector, the position vectors. Okay, so it will be negative of this one. Okay, so it will be totally different compared to the previous one. Okay, so this is F21. Now let's look at one example here. Alright, now let's look at one example to find the force between two charges. So usually the question won't be straightforward. It will ask you to find many things, then in the end only ask you to find the force. Okay, let's look at this example. So it is given that a negative point charge. Okay, so now you have a QA. Okay, so it is a negative charge. It's located at these positions. And another point charge QB is located at these positions and they are in free space. Okay, so highlight the informations. So let's look at the first question. It's asking you to illustrate the location of these charges in Cartesian. Illustrate means that you have to draw the positions of these charges in Cartesian coordinate. So we have learned about this in our multivariable calculus, how to draw these things. So first of all, we have to draw the axis, right? So we draw the axis. Okay, let's look at the first point. Okay, so it is negative 6, 4, 7. So this is x, this is y, and this is z. Negative 6 meaning that it is in these directions. Okay, negative 6, right? Negative 6. So negative 6 might be here. Okay, so this is negative 6. Positions y equals to 4. Okay, 4 might be here. Okay, and Z. Okay, so what you do is, if you still remember, so we construct the line, right? We extend the line. So we extend the line here, and then we get the intersection point. So we get the intersection point here. Okay, so this is the point, intersections. Then we are going up 7 units. So given going up 7 units. Okay, so these positions will be your positions for QA. And then for the QB, and then the coordinate is this one. So we'll go to the x equals to 5, y equals to 8. Okay, so you extend the line, right? If you remember, I told you before, when you extend the line, you have to make sure it's parallel to axis y, and this one is parallel to axis x, so you get the intersection point. And -2, you have to go down for 2 units. Okay, so this is the positions of your QB. All right, so this is the first question, so you have solved it. Okay, illustrate the locations of this point in the Cartesian coordinate. Determine the distant vectors. Okay, now you need to find what is the distant vectors and from point A to point B. So point A is the starting point and point B is the ending point. Okay, starting and ending. So we have done before to find the distance vectors. Okay, is A to B, right? So we will use this one, A, B, to represent the distance vectors. So we will take the position vectors of coordinate QB. So it is 5, 8, -2, minus the position vectors of QA, okay, which is 4, no, -6, -6, 4, and 7. Okay, follow the questions, follow the questions. So the positions vectors would be 5, 11, 4, -9. Okay, so this is the position, distant vector, sorry, the distant vector AB. So we have complete the question B. Okay, now the question C, they tell you if the charges of the QA and QB are -20 micron. Okay, so this one is -20 micron, and the QB is 50 micron, 50 microcoulombs. Okay, so for the vector force exerted on QB due to QA. Okay, read the questions. Solve for the vector force. They are asking you to find the force exerted on QB. Okay, so this is your QB. Your QB is having a force, right, because of the QA, due to QA. Okay, so you see, this is now QA exert force to the QB. Okay, so the force that you are going to find will be FAB. Okay, after you have clear about these things, so you have to write down what is the force that you have to find. This is the FAB. So we go to the C, finding the FAB. Okay, so what's the formula? So we have to apply the Coulomb's law. Okay, so this is the formulas for the Coulomb's law. So you have QA and QB here. Oops, QB. Divide with 4 pi epsilon naught. Okay, and here you have the R what? Follow this one. RAB square, and then you have a unit vector RAB. Okay, so this is the formula for the Coulomb's law that you have to apply. Okay, next, replace the value, right? It's very easy, replace the value. So QA is -20 micro and QB is 50 micro. Okay, so you write down -20 micro. You have to insert negative because this is a negative charge. Okay, and for the QB, it is 50 micro. Okay, when you see that this is 50 micro, it means that this is a positive charge. Okay, C, Okay, here you see a C, right? Coulombs. Okay, so this C stands for the unit. So you don't need to insert the unit. Okay, just insert the micro, everything. So divide with the 4 pi epsilon naught. Okay, epsilon naught is the constants. So now you have to find the values of these RAB. Okay, so this value we can get it from here. Distant vectors, right? So just now we have calculated these distant vectors. So it is actually RAB. Same thing. The distance between 2 points. So if you want to find the distant vectors, what you have to do is you're getting all and then you square it, right? 4 square plus -9 square. All this we have learned in the multivariable calculus. Okay, so you must still remember again, right? So it's 11 square plus 4 square plus 81, and then you square root the answer. Okay, is equals to, okay, you can leave it like this, it's fine, square root 28. Okay, so square root 28, if you square it, it will become, no, 28, 218, sorry, 218. Okay, you will get this. Okay, because you square it, and this one, it will become 11, 4, and -9. Okay, so this is a vector quantity, and divide with square root 218. Okay, so what is this? This is a unit vectors RAB. So if you want to find this unit vector RAB, you have to apply this formula. RAB, the vector RAB divide with the magnitude of RAB. Okay, that's how we come up with this one. Okay, so now you can start calculate. Okay, you can start calculate this. So you get this 2.8. Okay, and milli multiply 11, 4, and -9. Okay, so you can continue 2.8. So this is 30.8. Okay. So 11.2, -11.2, and positive 2.8 and 9. So 25.2. Okay, milli. Okay, milli, and now you are calculating the FAB, right? So this is the force. The unit of the force is Newton. So it's a millinewtons. Okay, millinewtons. Right, so this is how we write out the force for the AB. So if you write it in complete way, you have to write in this way, 8.8 x minus 11.2 y and plus 25.2 z. Okay, millinewton. Okay, so in the multivariable calculus, we are not using the x, right? We're using the I. We're using the J, and we are using the K. But for this subject, EMT, you are going to use these notations, X, Y, Z, to represent the directions. Okay, to represent the directions. So this is FAB. Okay, how you apply the formulas to calculate the force. And next, we go to the D. find the force exerted on QA due to QB. Okay, so you write down again, exert the force on QA because of QB. Okay, can you see the difference between these two? So now they are asking you to find the FBA. Okay, FBA, yeah? So FBA. So let's go for the FBA. So what is the formula for the FBA? Okay, so same formula, you still have QA, you still have QB, you still have 4 pi epsilon naught, and RBA is here, okay, RBA square, and unit vector RBA. Okay, again, make sure they are the same, because if they are different, okay, the direction will be different. Okay, so what is RBA? Okay, maybe the first thing that you have to find is you find the vector RBA. Okay, that is you're taking the positions of A minus the position vector of QB. Okay, so refer to the coordinate. So it will be negative 6, 4, 7, okay, minus this one. Okay, negative 6, 4, 7 multiply 5, 8, negative 2. Okay, 5, 8, negative 2. Right, so you will get negative 11, negative 4, and 9. Okay, so if you compare this one, the answer here and the answer here, you can see that the RAB is negative of the RBA. Okay, RAB is negative of RBA. Okay, so this is the relationship. So after getting this, I think you might need to find the magnitude. So we will go for the magnitude. Okay, so the magnitude is the same things. 11 square plus negative 4 square plus 9 square and square root. So same thing, you will get square root 218. So now you can plug in to the formulas. This is BA, okay, so right, wrong. So you have negative 20 microcoulombs and you have 50 microcoulombs. Okay, you can skip these coulombs. And then divide 4 pi epsilon naught, and you have these 218, okay, because you square it, and over here you have negative 11, negative 4, and 9, and here you have square root 218. Okay, because this one is the unit vectors. Okay, so the difference, okay, of this calculation and the previous one lies on the directions. Okay, negative of it. So the answer will be still the same. So you can calculate, try yourself. You will get 30.8 in the x directions plus 11.2 in the y directions and negative 25.2 in the z directions, and they are milli-Newton. Okay, so this is the FBA. Okay, you can calculate. Now let's look at the last one. Based on your calculation in C and D, okay, C and D, what's the conclusions that you can make? Conclusions. So you can compare, okay, FAB is, and also the FBA. So you can say that FAB is equals to negative of FBA. This is your observations. Alright, so this is the answer for the last one. Okay?